Hey guys, Mr. Backerberg here. In this video, we're going to look at applications of inverse trig functions. Now in this example, the bottom of a 20-foot replay screen at Dodger Stadium is 45 feet above the playing field. And as you move away from the wall, the angle formed by the screen in your eyes changes. There is a distance from the wall at which the angle is the greatest though, and we want to find that distance. Now we're going to start by drawing ourselves a picture, and we're going to end up with a right triangle where you are standing some x distance away from your wall. Now we know to the bottom of the screen it's 45 feet off the ground. And then it says that the screen is 20 feet long, so up to the top of the screen, that's an additional 20 feet. Now there's going to be a few different angles that we're talking about in our pictures. And the first angle I want to look at is the big angle going from the ground up to this dotted line. And I'm going to call that my theta 1. I'm going to call this little angle going from the ground to that red line, I'm going to call that theta 2. And then this little small angle up at the top between these two different hypotenuse lengths of our triangles, I'm going to call that theta. So what we can say in here is if we wanted to find the measure of just that regular theta angle, well, theta 1 is covering the entire angle down here on the bottom, and theta 2 is covering the piece just within our red triangle. So if I wanted to find just theta, I would have to take theta 1 minus theta 2. Now, based on the information that we've got in this picture, theta 1, as we're looking at this largest triangle in here, we can actually set up an inverse tangent ratio to help us find the measure of that angle. So theta 1 is going to be the inverse tangent. Now remember, with a tangent fraction, we do opposite over adjacent. So opposite of that theta 1 would be this entire side of our triangle. So that's going to be 65 over the adjacent side, which is just x. Similarly, if I wanted to find theta 2, we're just focusing on the smaller red triangle. So if I do the inverse tangent, opposite of theta 2 is the 45, and adjacent to theta 2 is the x. So I can replace theta 1 and theta 2 in my equation for theta with these inverse tangents. So then I could say theta is equal to the inverse tangent of 65 over x minus the inverse tangent of 45 over x. And if I want to figure out where theta is its biggest, I think the easiest thing to do would be to graph out this equation on a calculator. So in my calculator, I have that equation typed in as my y1. I did change my mode into degree mode, and I did adjust my window. I made my x min and x max go from 0 to 500 because that's our distance away from the screen. And I made the y min and y max go from 0 to 15 because that's going to represent the angle. Now when I hit graph, we'll get a picture that looks something like this. We are looking for the distance where the maximum angle happens. So I'm looking at this maximum point on my curve here. So I can go second trace, pick option number 4, the maximum. I'll have to arrow over to the left-hand side of that highest point and hit enter. And then I'll arrow over to the right past that highest point and hit enter, enter. And that tells me that my maximum angle, which is 10.5 degrees if we do a little rounding, happens at a distance of about 54 feet. That's going to be it for this video. Thanks for watching.